Let's move on to our third speaker.
So folks, I'm going to show you results from work we've been doing over the last 4 years in IBM research in smart cities. The reason it's called Smarter Cities, it turns out somebody had already taken the brand Smart Cities, so IBM decided we need to be smarter. It wasn't a comparative issue, it was merely a branding issue. So, observations from smarter cities, from cities in general, is that they waste a lot of resources because there's no one place where you can see how they're being used. So if you can provide solutions that provide an answer to that question, you solve one of the big challenges, and I'll show you how that could be done. The city agencies really work together when there's an emergency, but when they do that, they throw everything at it because there's no way of managing the resources and knowing what the outcomes will be. As we mentioned before, cities really need to communicate with the denizens, but they have no good methods of doing that and receiving input. The other thing is that people gather a lot of statistics about cities, but the statistics don't help cities figure out what they need to do. They give a glimpse. So when we first started with cities, we had our consultants go and visit Stockholm and say, hey, Stockholm, do you know how many miles, how many kilometers it takes before they find a parking spot in Helsinki? And say, oh, no, what's it like in Stockholm? We'd start off there, and then the discussion stopped because what do you say next? And so our objective was, in the research division, to understand something about how cities work, to understand how to solve some of the problems and make money out of it. Our objective in IBM is to create value for the corporation and its shareholders, and the research division is measured on just that. So we sent, as it were, the mathematicians into the sewers, and I'll show you what happened as a result. One last thing. Think about the professions that manage cities. The developers, the architects, the planners, the engineers, the people who run the city. The amount of information that's transferred between them is very small. So as an architect, for example, I could build an agent-based model that shows how quickly it takes for people to evacuate from a building. And that would be quite valuable for the emergency services to know. But that model, if it's created, is never passed along. Why is it that if I were to build a 5-story city in Twickenham, I couldn't figure out how many chickens would have to be killed to provide services on British Airways from people flying from New York to London Heathrow? Why is it I couldn't know that? Actually, you could. I'll show you how that could be done. Why is it that in traffic measurement situations, the way they get origin-destination pairs is somebody walks around with a clipboard and asks the drivers in the street, where are you going from and where are you going to? Aren't there better techniques for doing that? Yeah. So there's a new business in connecting the data across those professions. There's a new business in running cities by providing the agencies the information. And there's a new business in helping cities figure out what happens if. I'd like to show you some examples. Before I do that, this is the conceptual model we had about cities. Cities have assets, building roads, wires and pipes. And what do you have to do? You have to fix, repair, renew, and some best ROI, whatever the ROI is. So the mathematics of that are spatial-temporal analytics and optimization of use of resources. Through the city runs energy, traffic, water, people. And the objective function is to manage demand versus supply as best as you can. Why? Because you waste less if you do that. And then finally, how do we get input from the denizens of the cities that can help us operate them better? That was it remains one of the largest challenges that we have. So as we evolved our ideas, we said, let's go figure out what happens in transportation. And sometime at the beginning, a lady called Laura Winter went on a sabbatical to Singapore. And she developed a first model, predictive model of what traffic volume would be against in different arteries in Singapore. We started looking at that, but then we started looking at other things like water usage. We started looking at energy usage. We looked at all these different domains, and we found that there was no place where anybody looked at the value of all of that information to improve the efficiency of the use of capital. We then started looking at the city operational parameters and started developing predictive models, which I'll show you. Then we started trying to get to this ultimate goal, which was how can we bring the data together so that people can ask a question. If it rains, how many more pizzas am I going to sell? And by the way, there's a huge correlation between the two. Right? Typically, for companies that deliver pizza, they deliver 30% more pizza when it rains, and they double their deliveries, they double their output when there's a storm. Why? Because people don't like to go out. But you can imagine the logistics of delivering the flour, the whatever it is, to the right stores in the right time are critical. So IBM's developed, researchers developed a predictive weather model that's accurate to over 1 kilometer, rather than the 20 kilometers that normally you get. And by the way, we used this weather model to help Rio figure out how much rain was going to fall in the areas of the favelas across the whole city, because then they could figure out what to do to prevent emergencies. So I'll describe this later, but we provided the weather prediction, the rainfall prediction, and the flooding prediction for the city of Rio, so they can manage their emergencies, which happen a lot in the spring. That's how we evolved. Some examples. How do we do this? We usually basically use maths. We look at data to find the patterns. If you have a pattern, you can predict the future. Use mathematics to clean data. It's so often that you find that data comes off GPS systems, for example, tells you you're in a completely different place than it actually is, for various interference reasons. There's so much dirty data comes off sensors, and so much dirty data comes off all of us. For example, the names. You can have a name Jurij R. Paraszczak, you can have Rostislav J. Paraszczak, or you can have any combination. It's all the same person, but unless you have a system which cleans that data and identifies me uniquely, the data is useless. And then, obviously what we try to do is to use the data to optimize against a given objective. Some very early examples. This is from we hired a gentleman from MIT, and they did a study that showed who called who across the United States. You can see there's some coherence between the regions. So why do you care about that coherence? Because you can provide services that are targeted against that coherent set of individuals. You can help cities, you look at finer detail, you can help cities plan where to put the cell towers. This is just kind of the beginning of it. Here's another thing I'd like to show you, which was done much, much later by a gentleman called Milind Nafta and his team in, can you turn the audio up on this, please? In Istanbul.
In Istanbul, Turkey, the city's population on the Asian side of the city is expected to double to 9 million people by 2025. To help address the massive increase in demand for public transport, the city is investing in new rail infrastructure. IBM is working in partnership with Istanbul Ulaşım, the city's transportation authority, and Vodafone to build an understanding of where public transportation is required using the privacy-protected data collected from mobile phones. The first-of-a-kind project uses IBM Research Innovations to map billions of pieces of data collected from millions of mobile phone users each week. This big data delivers rich geospatial information in real time that reveals how people move through.
Notice the color refers to the derivative of the number of people. That's how many people going in and out at any one time.
The city. Insights are then extracted from the data to show a heat map of the density of people during peak commuter periods. IBM is using this information to scientifically model bus routes that connect to the city's new rail line. Managing the different transport systems, road, rail, and buses, as one system of systems allows for the optimization of all and improves the user experience.
So, before you ask, the data was provided by Vodafone to us only in Istanbul. We couldn't take it out of Istanbul. We couldn't take it out of the building. We had to do all the analysis there. Each cell phone number was given a random number. And so, yes, over a week's time, when that random number stayed with that phone, you could sort of understand the patterns of who was moving where, but you didn't know who they were. And so what we found from that was that there's a lot of data that you can extract that can help you decide what you can do to predict what needs to be done for a given set of resources. This is a list of just some of the projects we've done. It's just to explain that for each of these projects, about 4 or 5 people working for about a year in a particular area, or all around the world. Here's one that evolved from, I'll show you a video of probably what's a definitive kind of project that explains what data can do to help.
This is actually a critical moment for water infrastructure in the United States of America. In Washington, D.C., the average age of a water main is 77 years. It was put in generations ago. We have sewer lines and water lines that were put in before the Civil War. And the infrastructure has been aging ever since. We got a failing system, we have ever more stringent requirements, and we have a customer base that's not used to thinking about what we do unless it's a problem because there's been a break of some sort. There is more work to be done in our system than we can ever get to in the next 50 years. The only way that we see making it through those challenges is if we can demonstrate to the people we serve that every dollar that we gain from them is being efficiently and effectively used so that every dollar is going farther. We have got to have the best available information. We've got to use it up front. As of 5 years ago, we didn't know what kind of fire hydrants, what condition they were in, what order they were being maintained in. We respond to water main breaks when they happen. We respond to customer service complaints when they happen. It's all a responsive mechanism. It's almost the way policing used to be, which is you judge yourself by how fast you respond to the problem, rather than anticipating what the problems are and trying to head them off ahead of time. Now it's instantaneous. What we're doing at DC Water in connection with IBM is really fundamental. We're collecting information and then using the information to make better decisions about how those assets are deployed or managed and operated. You collect those together in an analytical framework, then all of a sudden you start seeing where it's most likely a water main break is going to occur, and we can go out and get it ahead of time. We're now using analytical to make sure we get the worst pipes first that are most likely to cause a problem. That means collecting information about soil type, age of pipe, how often there's been breaks, what are the pressure issues in the city. Every single hydrant in the city has been cataloged. We've put that same GIS-based data model in all the fire trucks. Because we've been able to optimize truck routes in places where they're doing similar work or anticipated work using this information we're collecting, we've saved 20% on fuel costs. And we've saved over $1 million because we only roll to the places where we know there's a problem, which we are alerted to in advance. We have often found, responded, and fixed a problem before the customer even knows happened. That's been a 100% improvement over our response rate to the problems we have to our customers in the city. And these analytics are allowing us not only to know how we can do it, to prove that we are doing it. But you end up with an upward cycle which can only deliver better service and actually make it an incredibly fun place to work. We've been able to do more with less, and do that on behalf of every home, every business, every visitor. Everyone in Washington, D.C. relies on the services that we deliver.
So, lest you think this is corporate propaganda, let me give you some background as to what happened here. Washington, D.C. had bought this software called Maximo. It's an asset management system that tells you where the pipes are, who laid them, when it was repaired, when it was bought, everything you possibly could know about the sewers and the hydrants and the pipes. And like you said, cities have a lot of data, but they had no idea what to do with it, right? So we brought in a group of statisticians who started doing clustering. And all of a sudden they find, hey, you know, there's a correlation between the time of year and the leakage of a certain part of the main, which was, by the way, installed in pre-Civil War days. By the way, anybody know what kinds of water mains were installed pre-Civil War? What was the material made of? Wood. Wood. Actually, it's surprisingly resilient when it's wet, right? In any case, so, you know, we started building predictive analytics that said, this is what is likely to happen. And do you think they went and dug up the road when we said that? Absolutely not. But what they did was they set aside money that they thought might be needed for that. They began to have understanding of scale of what had to be done. And then one day, they're on the phone with our team, and somebody, George, I think, said, hey, and when they start digging that up, let's get underneath it. We said, what do you mean? He says, well, they're going to dig, somebody's going to dig up the road. We know there's a leaky valve. Let's go fix it. Which is like this, you know, this problem digging up the road 3,000 times. It's a well-known phenomenon. And so we said, can we find a way in which we can get agencies to work together, to work together better? And it was very difficult to find a city that had that ability. One city that we did find was Cambridge, Ontario, in Canada, as opposed to Massachusetts. And for them, what we started focusing on, was planning. What did we do? I mentioned before that in their planning sessions, they had the different agencies that were responsible for all these different parts of the infrastructure decide how much money they would need for the future. And they built their plans in a fairly simple way based on spreadsheets and based upon the best known information they had. But what we did was we looked at all of these components, again taking the asset management system and understanding the infrastructure. What was the infrastructure like? So for example, in the top right, what you can see is a year on the x-axis and the remaining service life of a road, a sewer, and a water pipe. These are sort of idealized. But these numbers are available, right? So imagine you have the whole city. Imagine you know where the bridges are, which you do. Imagine you know where the assets are. Imagine you know when they were installed. You now have a heat map of what's likely to go wrong where. Right? And if you decide that you're going to replace the concrete on a spalled bridge that has the rebar showing and rusting, before you start repaving the road, you might save a few dollars because of the sequence in which you do this. And you can tell how much money you're going to need if you fix one thing ahead of another. And so this predictive analytics, essentially what it did was, it looked at the instructor profile. It predicted you what was going to fail first. You made a decision, what am I going to fix first, how much is it going to cost me, and what's the impact on fixing it later. So instead of making guesses, you now have a predictive system that tells you what will happen if you develop a certain approach. So for us, this was an eye-opening experience where instead of competing for funds, they started working together and providing information that's geospatial, a map, providing information that allows the different groups to work together and see what each other are doing, helps them figure out what to do, and that's what they're doing. We've put this into our product, and many of the companies, as many of the city agencies and regional agencies are starting to use this in Canada. On the second side, just as you can plan for a problem, you could deal with the operational side of it. One's long-term view, one's a short-term view. In every city, what is it in the city that predicts what's going to happen for a planned event? Anybody know? Permits. The permit tells you what's going to happen, right? And so you can figure out the planned events. You don't know what the unplanned events are, but what you can do is prevent stupidity happening. So in one city, what was happening was the police were directing traffic to a festival right through an area which is under construction, which you can imagine how well that works. This happens all the time. But if you provide the information that can be shared on a map with a schedule and a timeline as to who's doing what and where, you can start helping the city understand what they need to do and how. And so we started off doing this with Minneapolis and began to understand, okay, so this is the triangles are where the road construction are. We can figure out what's going to happen and where with the traffic. Can we reroute the traffic? If it rains, what can we do? So just as we described this notion of a predictive analytics center, that's where we're headed with this. But to do this, we had to learn the following. What were the patterns? How do we use our software to manage those patterns? So just as you can fix roadways and bridges, you can fix oil rigs and factories. It's the same problem over and over again. So we learned what software stack to put together for that problem, what size of problem we had to deal with. And these sort of issues in cities that happen lots, which is wasting money because they don't have the information, can be resolved with these kinds of approaches. And essentially, you know, what we're going after is a set of analytic tools that help cities deal with emergencies, operational situations, planning, that help them answer the question, what if? And that's it.
Thank you. Any specific questions for Jurij before we start to quiz the whole panel? Gentleman in the blue shirt.
Yeah, I think I really enjoyed your presentation with the examples of sort of the use of analytics in the city.
Yeah.
And I was hoping, I guess, the panel as a whole could sort of articulate a little bit for us your vision of what role government ought to play and what role perhaps government ought not to play in the creation of a smart city, one of it being perhaps improving existing functions. One of it, I think, was mentioned in the first place of, well, can you sort of facilitate the creation of this ecosystem, let technology happen on its own? What are the lines that should be drawn of, here's the things that a city or a government entity is good at, and here's the things where it should just get out of the way?
So, should I? Yeah. So I think the first thing the city is good at is politics and dealing with its denizens better than anybody else, right? And the first thing they should do is make data available in ways that are consumable by the companies and anybody else that can help them create value. So a data structure, a common data structure, is probably a good place to start. But a second thing is recognizing that data scientists should work with them to help the data scientists understand the problems of the city and help the city understand what the data scientists can do to help them. Because right now there's a fair amount of disconnect. However, you know, groups like the ones in Chicago, groups like the one at New York, groups like the one at Imperial are beginning to create these data scientists who have a training related to cities. Right? My belief is that there's a revolution going to happen which is going to take this data and make it usable for cities. I'll hand it over to my colleagues.